Now, integration using trigonometric identities. We have a number of trigonometric identities. For example, cos 2x equal to cos squared x minus sin squared x, again equal to 2 cos squared x minus 1, again 1 minus 2 sin squared x, and so on. Sin 3x equal to 3 sin x minus 4 sin cube x. Similarly for cos 3x tan 3x. And again the product rule, the sum rule, so many identities are there. So we can make use of these identities to perform integration. That means the given function will not be in the standard form. That may not be in the list of standard functions. So applying these identities, we can reduce the given function into the standard form. That means we can immediately write the integral, that's all. So, integration by trigonometric identities means we use trigonometric identities, apply trigonometric identities to reduce the given function into the standard form and then we integrate. That's all. So, for example, suppose we want to integrate this sin squared x. This is not in the list of standard functions. We do not know the integral of this sin squared x directly. And then what we do is, we have this result, cos 2x is equal to 1 minus 2 sin squared x. 1 minus 2 sin squared x. And then 2 sin squared x is equal to 1 minus cos 2x, and sin squared x is equal to 1 minus cos 2x divided by 2. And hence, this integral of sin squared x dx is equal to integral 1 minus cos 2x divided by 2 dx. Applying this result. Which is equal to integral 1 by 2 dx dividing 1 by 2 and 1 by 2 dx minus integral cos 2x divided by 2 dx. Cos 2x by 2 dx. So this is equal to 1 by 2 constant taken outside, integral dx which is x. So x by 2 minus, here again 1 by 2 taken outside, integral cos 2x dx. Here cos 2x dx is actually not in the list of standard functions, but here we apply the substitution method, 2x is equal to t, and then integrate. We know how to integrate. And the integral will be sin 2x divided by 2 plus constant of integration. And here we apply this substitution method, but actually since the integration of this cos 2x comes as an intermediate part of this integration process, we need only directly write the result which we know. Need not substitute separately 2x is equal to t and find the integral. No, it's not necessary. So directly write the integral, and this is the integral of the given function sin squared x, which is equal to x by 2 minus 1 by 4 sin 2x plus constant of integration. So here we applied this result. Why we have chosen this for sin squared x? In this cos 2x equal to 1 minus 2 sin squared x, there is sin squared x. And the remaining part is this 1 cos 2x divided by 2. 1 cos 2x. We know the integral of cos 2x, or we can find the integral of cos 2x. That we know. Identify all these. From this, separate sin squared x. In the remaining portions, if we separate sin squared x, we get this. And these are all integrable. We know how to integrate, or we know the integral of the separate 1 by 2 cos 2x by 2 separate expressions. That is why we have chosen. Similarly, suitably choose the identity. When we apply this identity and reduce the given function in the standard form, we can immediately integrate. And remember, when we use this identity, when we separate that function which is to be integrated in terms of the other functions, those other functions should be with the non-integrals. That is important. Okay? That's all.